All right, today we're going to answer this question. Going to give you a second to read it. We got a closed box, and I don't know what's happening here. We got a closed box. It's got length x, width y, and height h to be made from 300 centimeters squared of thin metal sheet with the perimeter of the base is said to be 40. We're going to start with that final part. The perimeter of the base is 40. So here is my base of my shape. One is x and one is y. And we have height h. I'm just going to draw it in the wacky third dimension here. And there it ends up being like that. So we know the perimeter of the base is equal to 40. So the perimeter is equal to x plus x, opposite sides of a rectangle are the same, plus y. So it's 2x plus 2y, and that is equal to 40. That's going to be our first equation. Like that. We also know the volume. The volume is x, y, h. We also additionally know one other piece of information, and I can't draw it up there because it's going to go crazy. It's to be made from 300 centimeters squared of thin metal sheet. So that means the surface area of the box must be equal to 300 centimeters squared, because that's what I'm making it out of. So the surface area, which is 2 times the area of the base, which is xy, plus 2 times the area of one of these faces that I'm shading on the side here, which is YH, plus 2 times the area of the back face there, which I'm shading again, x2, xh, the area of all 6 sides of my rectangle. So we've got all these different formulas. Eventually, we want something that looks like this, which means if this is our goal, we want to take this formula, this phi formula, and we want to replace x and we want to replace y. And we're going to replace it using the 2 formulas that we have just found, one for x and one for y. Let's take the perimeter one first. And what I'm going to do with this is I'm going to rearrange this to make y the subject. So I'm going to take away 2x from both sides and divide everything by 2. I'm then going to take this, and what I'm going to do with this, I'm actually going to put this into my volume formula. And the reason I'm going to do this is just so I can, because I know my end product, I can begin to see what I'm working towards. So we have 20 xh minus x squared h. Remembering that if I was to rewrite this a little bit differently, I could write it like this. Remember, multiplication is commutative. The order doesn't matter, I can move it around. This is what I've got here. So what this is telling me is this surface area formula, I'm going to need to rearrange to make y the subject. We know what the surface area is. It's 300 in total. I also have an expression for y, which I'm going to substitute in because I need something for x here, as you can tell. We have 2x, 20 minus x, plus 2y, y, and by y I mean 20 minus x, plus 2xh. We've substituted for y. Let's expand. So we have 40x minus 2x squared plus 40, there should be a h here, plus 40h minus 2xh plus 2xh. We're going to get a bit of cancelling here. These two are going to cancel, and this is what we're left with. 300 equals 40x minus 2x squared plus 40h. We can also divide everything by 2, and I'm going to do that right now. And you can see that we are getting much closer to what we need to find. Now, the only issue I have here is we have this, and I need to put this into that volume formula that I just created somehow. This is where things are going to get a little bit weird. Putting in x is going to be difficult because we've got this x squared. But what we can do is we can replace that x squared with the x squared that I have here. So If I isolate x squared, I'm going to add x squared to both sides. So I have x squared plus 150 is equal to 20x plus 20h, and then minus 150 to get x squared by itself. If I was to substitute that into that volume formula, and then I was to expand it, minus 20xh minus 20h squared plus 150h, these two are going to cancel, and look what I'm left with. 150h minus 20h squared, which is what the question is asking us to find. The hardest part that we have done. We aren't over yet though. We want to find the dimensions of the box that meet the requirements and has the maximum possible value. So to find the maximum possible value, we're going to need to differentiate it. The derivative will be 150 minus 40h. We want to find when it's stationary, so when this is equal to 0, 40h is equal to 150. Divide both sides by 40. Oh, this number's going to suck, and my calculator is right here and not out of reach. So my value for h is going to be, divided by 40, 3.75. We want this to be a maximum possible volume. So I'm going to need the second derivative, which is always less than 0. Therefore, h equals 3.75 is a maximum. Because if the second derivative is always less than 0, then it will always be a maximum. And that value, because that is the stationary point, it will be the maximum of my curve, or my imaginary curve I've drawn. Now I've got this value here, I'm going to need to find x, and I'm going to need to find y. This right here is what we have for x. It's going to hurt. We've got x squared is equal to 20x plus 20 times 3.75 minus 150. Let me just rub away this y. So we have x squared equals 20x, 20 times 3.75 plus 75 minus 150, x squared, and I'm going to put x squared equals 20x minus 75. Let's put everything on one side of the equal sign. That's going to be important because then I'm going to be able to solve this. X squared minus 20x plus 75 is equal to 0. I need to solve this quadratic. I need two numbers. They're going to multiply to give 75, add to give negative 20. The question we're going to need to ask ourselves is, what are those numbers? Now, mercifully, as I sit here and do it, I'm going to be able to help you out with this. It's going to be minus 15 and minus 5. Minus 15 times minus 5, that's positive 75, and minus 15 minus 5 is minus 20. Equals 0, so we have x is equal to 15 and x is equal to 5. Two different x values for this. I didn't think we're going to have two x values for this, but that's just how we ride, you know. That's just how we do it. Now we can go back to our y. 20 minus x. So y is 20 minus 15, which is 5, or y is going to be equal to 20 minus 5, which is 15. So the reason we end up with this is because of how we've essentially constructed our equation. We notice that these end up being pairs. So when I'm picking my answer, I only need to pick one of these two pairs. Therefore, x is going to be 15, y will be 5, and the height is 3.75. And these dimensions give us the maximum volume of this shape if I was to multiply it together. And the maximum volume itself is 281.25 centimeters cubed. Very difficult question involving maximum and minimums. A lot of working out, a lot of different things happening here.